10.4, we're talking about inscribed angles and polygons, and we're still dealing with circles. So all of these things are going to come in circles. Big word today is inscribed angle. We've worked with central angle in chapter 10, but this is the first time we're seeing inscribed angle. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So, in 10.1, we talked about this central angle. When we have a vertex in the center, and we have two radii going out to our edges of our circle. That's a central angle. Inscribed angle is a little different. Now, we have our vertices on the circle, and then any two chords that create this angle. That's an inscribed angle. An arc that lies between two lines, rays, or segments is called an intercepted arc. So here we have that inscribed angle in the blue, right? That's an angle here. This inscribed angle. Okay. The arc that connects your two dots is the intercepted arc. And then it says a polygon is an inscribed polygon when all of its vertices lie on the circle. Okay, we actually do have an inscribed polygon here. It's a weird looking quadrilateral. Oh, no, just kidding. This is not an inscribed polygon because all of its vertices are not on the circle. Okay, we'll get into some examples in a little bit when all the vertices are on the circle. We're going to skip this. We're going to skip this. We'll prove that in a little bit. We do have a few definitions, however. All right, the first word we're going to define is subtend. Subtend means kind of to create. So let's see what to write down here. If endpoints of a chord I don't know why I drew a comma there. That's going to bother me. I apologize. All right. If endpoints of a chord or arc lie on the sides, of an inscribed angle, then the chord or arc is said to subtend the angle. Okay, so when you hear subtend, I think of create. It creates the angle. An example here, right here, if we have this arc, this chord, this is a chord. If we have this chord, then this creates this angle, or subtends this angle, and that's what we see here. Okay, segment AC or chord AC subtends angle B. It creates that angle. The arc for AC it subtends this angle. Okay, that's what you see here. Okay, that is subtend. Inscribed polygon, that's when all points, or all, let's say all vertices are on the circle. In a circumscribed circle, is the circle. Oh, need to learn how to spell first. Holy cow. The circle that contains the vertices. And for example, if I have a circle with all points of any polygon, we'll just say this one here. Okay, here's our shape. So this is an inscribed polygon because the polygon is inside the circle. All vertices are on the circle, and the circle around it is the circumscribed circle. Okay, if we have a inscribed polygon, then we have a circumscribed circle. That's it. Nothing too difficult or tough to understand there. Okay, now we get into some definitions or theorems here that are very important through 10.4 and the rest of chapter 10. The measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So, we have an angle here at D. Okay, this is our inscribed circle. The arc that it forms, AB, okay, we were taught with central angle that whatever our central angle is, whatever the central angle is the same as the arc. This is a little different. Because it's an inscribed circle, now we're talking about little differences, or kind of a major difference here. It's not the same, it's actually twice the size. Okay, so for example, let's say I have an angle here. This looks like about 80 degrees. Okay, just a guess, whatever. I don't know it's 80, I just made that up. 80 degrees, let's just say angle D is 80 degrees. Okay. The intercepted arc is double of that. So this is 160 degrees, if that's 80. It's double. Vice versa, let's just say we only knew that. If that's 160, then we know this has to be 80 degrees. Okay. This one, little weird to see. If two angles, or two inscribed angles, remember, inscribed angle has the vertice on the circle. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So let's just start with D here. D goes to A and goes to B and creates this angle. Okay, the other inscribed angle that goes to A and B is C. Goes to A, goes to B. So they intercept, or they both go to the same arc. They both have this arc here, AB. Okay, that means that angle D and angle C have to be congruent. We just talked about this one a little bit ago. We're going to skip it. This one's a little unique. Inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse, remember the hypotenuse is that longest side of a right triangle. The hypotenuse is the diameter of the circle. Alright. On the other side, okay, flip that. If one side of an inscribed triangle is the diameter, then we know we have a right angle. And the right angle and the hypotenuse are always opposite each other. Right? Here's my right angle. We know that's right because this, AC, is the diameter. Okay, which has to be the hypotenuse. And the last theorem here. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so quadrilateral, you have to know what quadrilateral is. That's 4 sides. So any four-sided shape, okay, that is inscribed in a circle, its opposite angles have to be supplementary. So D, what's opposite of D in this case? F. They have to be supplementary. D plus F equals 180. Same with E and G. Okay? They have to equal 180. I can prove this in GeoGebra. Just really quickly, let's delete that. Just create a circle here. Circle the center. Okay, there's our circle. Now, if I create a polygon inside that circle, it has to be quadrilateral. Just anywhere, put all vertices on that circle. It doesn't really matter where. We'll go down here, and then we'll go, let's just say up here. This is kind of tough to see. Let's move this. Now think about opposite angles. Let's find angle D and angle F. These two should add to 180. Okay, there's 84. Well, we'll say 85 because that's really close to 85. 85 and what is that? 95. We add these. 85, 95. 9 plus 8 is 17, plus 1 more is 18, 180 degrees. Okay, so that proves it. The opposite angles of a quadrilateral inscribed in a circle have to be equal to 180, or have to be supplementary. Okay, down here. Extra practice. In exercises 1 through 5, use a diagram to find the indicated angle measure. The first thing they give us is angle A. We want to find the measure of this angle, and I kind of just gave it away. Shoot. We want to find this angle. Well, we kind of have to look at what we're given. We're given this angle here. That's 28 degrees. Okay. But that really doesn't give us a whole lot of information for angle A. What does give us a lot of information is this diameter. And we know it's a diameter because it's a chord through the center end. If that's the diameter, and we have a triangle, then we know we have a right triangle. And I know angle A is the right angle because it's opposite the hypotenuse. So I know that the measure of angle A has to be 90 degrees. Okay, let's label that. Next, we want to find angle C. Well, we already have two angles of a triangle, 28 and 90. So I'm going to take 90, 28, add those together, which is 118. And I'm going to subtract 118 from 180. I'll just do it, which is 62 degrees. Okay. Next, we want to find BC. BC, again, is the diameter. And to find the diameter, well, it's the hypotenuse. To find the hypotenuse, we have to take our two given sides, that's a squared and b squared, and set it equal to c squared. Okay, so we'll say BC, that's our hypotenuse squared, is equal to 7.3 squared plus 3.9 squared. Now I need a calculator. I have one right here. 7.3 squared plus 3.9 squared, 68.5. Have to take the square root of 68.5, and we're going to get 8.3. So BC is roughly 8.3. Okay. Next, we have to find the measure of arc AC. We have to find this measure. Okay. Now, your instinct is going to say, well, it's just whatever this angle is, which is 28 degrees. And that's not correct, because this is different than a central angle. This is an inscribed angle. When we have an inscribed angle, we have to double. A double 58. We have to, double 28. So we have to take 28 and multiply it by 2. Okay, which is 16, 2, 4, 56 degrees. Okay? We have to take 28, multiply it by 2, and that's the measure of the arc, 56 degrees. Now the next one is the measure of arc AB. Okay, well, AB, that arc, it's the inscribed angle that is, the inscribed angle that subtends from this arc, or is created, is this angle here. Well, what's the angle of C? It's 62 degrees. We got that right there. So to find the arc of AB, we have to take 62 and multiply it by 2. 62 times 2, 125 degrees. All right, that's 1 through 5. This one says name two pairs of congruent angles. Really, it's what two angles have the same arcs. So I'm going to start with A. A goes to C, and it goes to B. Now there's another angle here that goes to C and goes to B, and that is angle D. Okay. Since all of these angles are just kind of solo, I'm going to say angle A is congruent. Sorry, I didn't want to say approximately. I want to say congruent to angle D. Okay, because they both have this arc, right? They both have BC as an arc. On the other side. Start with B. This goes to D and goes to A. There's another arc that goes to D and goes to A, and that's C. So I know that angle angle B is going to go to angle C because they both have this arc here. Okay. And lastly, find the value of each variable. This is a quadrilateral inscribed in a circle. This is an inscribed polygon. It has to be quadrilateral, it has 4 sides. Remember, I proved this with GeoGebra, that the opposite angles, C and A, have to be supplementary. So to find angle M, that's equal to 180 minus 65. Angle M is equal to 115 degrees. Okay, angle N has to be equal to 180 minus 100, which is equal to 80 degrees. Okay, that is it for 10.4. If you have any questions, please email me or ask me in class.